Good day, sir, and to classmates. We are here to Group 4 to report topic that is given to us. It's about testing the tensile strength of the steel bars. So the content of our report are: what are steel bars? What are the classification of steel bars and how do we classify it? The significance of steel bars in engineering construction, how do we test its tensile strength, and lastly, the discussion about the tensile strength test.
So, good day to everybody. Before I will start, let me introduce my name. I am Bonifacio Ayaghong, and the task given to me is to report on what is or what are the steel bars. So, we define steel bars, which commonly known as reinforcing bars or rebars, and a mesh of steel wires used as a tension device in reinforced concrete and masonry structures. So in short, this is used to reinforce the concrete, and this steel bars is mostly used as of today in almost all type of concrete construction. And to attain the tension and compression stress, so steel bars is the excellent partner of the concrete. The history. It is originally concrete structure were made without reinforcement. So in short, before there is no reinforcement, so this we call the plain concrete. But in the early 18th centuries, rebars is started to use in the construction. And noon, yung cast iron lamang ang materials na ginamit sa rebars. Pero ngayon, meron na yung maraming types of steel bars which is used today in almost all kind of concrete. And some types of steel bars will later report by the next. So we'll proceed to the identification of the steel bars. As we see in the picture, there are markings in the steel bar. There is the rib, which is the line at the side of the steel bars. And ito po yung wala doon sa round bars. And then, makikita din natin yung M as the initial of the manufacturer. Yung pangalan ng manufacturer. At saka yung bar size niya. Meron din doon yung 6. So 6 mm yung steel bars. And then meron yung steel type niya. Meron yung A at saka yung N doon sa gilid na picture. And then meron din yung grade, which is 40, 50, 60, and 75. So we determine the grade by seeing the line in the side of the ribs. So if the line is 1, it is 60, grade 60. And then if the line is 2, this is grade 75. those markings in the steel bars ay makikita natin per meter in the steel bar. So, every 1 meter, meron po itong mga markings na mga ito. So, we will now proceed to the standard weight of the plain or deformed round steel bars in kilogram. So, makikita natin dito yung diameter of steel bars and then the length provided. So, we will see kilograms of steel bar. So, hindi ko na isa-isahin ito. Basta, makita naman natin dito yung weight ng mga steel bars. Halimbawa na lang itong 8 mm. If 5 meter yung haba niya, meron siyang 1.98 kilogram. And then, if 6 meter, meron siyang 2.37 kilogram. And if 7.5 meters, meron siyang 2.96 kilogram. And if 9 meters, meron siyang bigat na 3.56. And then, if 10.5 meters, meron siyang 4.15 kilogram. And then, if 12 meters, meron siyang 4.74. And then, if 13.5 meters, meron siyang 5.33. So, hanggang sa 36 mm, meron yung details natin dito. Punta na tayo dito sa different uses of reinforced steel bar. So, meron yung primary reinforcement used to provide resistance to support design loads. So, mostly itong primary reinforce makikita natin sa mga beams. And then itong secondary reinforcement used for durability and aesthetic purposes by providing localized resistance to limit cracking and temperature induced stress. So, makikita natin ang yung itong secondary reinforcement mostly na-apply dito sa flooring sa second floor and above. And then it provides resistance to concentrate loads, spreading it through a wider area. Another is assist other steel bars in accommodating their loads by holding them in the correct position. So, halimbawa na lang itong stirrups and then lateral ties, which is ang mga lateral ties na nakatay doon sa poste o di kaya yung column. So, meron yung mga outer ties, inner ties, and then straight ties. So, pati din doon sa beam natin, yung stirrups. Meron yung open stirrup, yung closed stirrup, and then straight stirrups or ties. And then the external ties bars to constrain and reinforce masonry structure sometimes as a means of building conservation. So, ito yung mga mostly mga cut bars. Kikita natin dito sa beam. And then yung dowels at saka pwede rin yung hanger sa ceiling and the partition. So, those are some of the uses of the reinforced steel. And then we include also in the masonry yung some masonry blocks and bricks include voids to accommodate rebars to carry tensile loads. The rebar is secured in place using grout. So, it is also used in the laying of hollow blocks and bricks, yung steel bars. So, meron tayong vertical bars at saka yung horizontal bars dito sa laying of hollow blocks and bricks. And then bars can be manufactured in various forms. So meron tayong round, and then square, twisted, ribbed, stretched, twisted, and ribbed and twisted. So makita natin ito sa next report dun sa type of steel bars. And then dito sa differences of plain concrete and reinforced concrete. So as we have said a while ago, in the structure, there are steel bars used that we called the reinforced concrete or reinforced cement concrete. And then yung plain concrete tulad ng mga pavement, and saka kung minsan hindi rin nalalagyan yung doon sa first floor na flooring, yun yung mga plain concrete. At saka yung mga reinforced concrete, yung mga mostly yung mga other structures like buildings and others. So yung pagkakaiba lamang ay yung plain concrete walang nagamit na steel bars. So this is the end of the number 1 topic given to our group. Thank you for listening.
Classification of steel bars and how to classify them. Prepared and reported by Winnie P. Gotana. The first classification is the carbon steel, which contains trace amounts of elements besides carbon and iron. This group is the most commonly used, accounting for 90% of steel production. Next are the alloy steels, containing alloying elements like nickel, copper, chromium, and aluminum. These additional elements are used to influence the metal's strength, ductility, corrosion resistance, and machinability. Third are the stainless steels, containing 10 to 20% of chromium as their alloying element and are valued for their high corrosion resistance. These steels are commonly used in medical equipment, piping, cutting tools, and food processing equipment. Fourth are the tool steels, which makes excellent cutting and drilling equipment as they contain tungsten, molybdenum, cobalt, and vanadium to increase heat resistance and durability. Types of steel bars. Deformed bars. Deformed steel bars have ribs, lugs, and indentation on the surface of the bar. Ribs provide bonding strength between the bars and the concrete. The structures become strong, and for its yield strength, works with bond concrete more that helps to withstand the structure during an earthquake or flood. The ribs ensures better grip in concrete. It reduces the possibility of slipping during construction. TMT bars are thermomechanically treated bars. Thermomechanically treated bars are hot-treated bars that are high in strength used in reinforced cement concrete work. Shown on the picture below are the different patterns on a deformed bar. The first one is a spiral shape, the next is the herringbone shape, and the third one is the crescent shape. HSD bars or high-strength deformed bars. High-strength deformed bars are cold-twisted steel bars with lugs, ribs, projection, or deformation on the surface. The cold working involves twisting or drawing the bars at room temperature. In terms of physical characteristics, the HSD bars are typically harder and stronger than the TMT bars. It is because, as the metal is shaped at the lower temperatures, the steel's hardness, resistance against tension breaking, and resistance against deformation are all increased due to work hardening. Mild steel bars. These are plain bars and have no ribs on them. As you can see on the picture below, the bars have no ribs or lugs on them. Their surface is smooth. They are used in concrete for special purposes, such as dowels at expansion joints where bars must slide in a metal or paper sleeve, for construction joints in roads and runways, and for column spirals. The mild steel bars are easy to cut and bend without damage. Pre-stressing steel. Pre-stressing steel is used in the form of bars or tendons, which are made up of multiple strands. However, tendons and strands are more frequently used as these can be laid in various profiles, which is a primary requirement of pre-stressing steel. PC strand or pre-stressed concrete steel strand is a twisted steel cable composed of 2, 3, 7, or 19 high-strength steel wires. The use of the pre-stress technique in concrete gives it greater strength by providing an internal compression force which counteracts the traction force produced by the loads of the structural elements. Pre-stressed concrete uses high tensile strength steel that is manufactured by increasing the carbon content in steel compared to ordinary mild steel used in RCC. In pre-stressed concrete, the steel used is tensioned or pre-stressed. On this slide, you can see some examples of decorative steel bars, which are commonly used to make gates, doors, porches, etc. on houses. How to classify steel bars. Steels can be classified through composition, the production method, finishing method used, form or shape, deoxidation process, microstructure, physical strength per ASTM standards, heat treatment, and quality nomenclature. And that ends my report on steel bars. Thank you for listening.
Good day, sir, and to your classmates. So, I will report about the significance of steel bars in engineering construction. I am Han Apigan, BSCE2, non-STEM. So, first, steel may be an expensive material, but its high strength makes it one of the most important parts of constructing a sizable concrete structure today. So, initially, concrete structures were made without reinforcement, not until the 18th century. So, later on, steel began to be considered a better material and still the most used material to reinforce concrete structures. And the number one significance of steel bars in engineering construction is the strength. So the steel bars add strength to the concrete structure and allow for more specialized designs such as cantilevered structures, so long structures anchored at only one end, and it also enables the use of thinner, less supported concrete slabs and promotes quicker construction times, to name only a few benefits. Also, its useful strength and tension and compression makes it 10 times stronger than the concrete itself, thus adding unmatchable strength to concrete structures. And when concrete and steel are combined, they make a solid reinforcement concrete. The number 2 significance or the importance is the durable structures. Alam natin ang steel isang durable structures. When thinking durability in a concrete structure, engineers consider the use of reinforcement with appropriate characteristics and quality. So the principal aim of characterizing a material is to make sure that it has the requisite properties needed to achieve the intended engineering usage. And to test its durability, this is done by checking the chemical composition and physical properties. The characterization of steel rebar makes them the ideal materials to get a sound reinforcement concrete structure with desires, strength, and durability. This prevents catastrophic failure of your structure as long as the reinforcement provided is not less than the normal requirement of your structure. So number 3 is the important. This is important for design. Syempre, important talagang steel sa designing when it comes to construction. In pre-stressed concrete structure, the steel bar is stressed before subjecting the structure to loading, thereby viewed as an active reinforcement. So passive steel reinforcement must be strong in tension and at the same time are ductile enough to be bent. Therefore, any design that a construction company wants is possible. So, it can be said that the bendability properties and its strength, it becomes a much preferred material for reinforcing concrete structures. So, last significance is it takes the tensile stresses. So concrete has a low tensile strength. That is, it can easily break when under stiff tension. This is probably the number reason why it should be reinforced with high tensile materials. So the high tensile feature from steel makes it ideal as a tensioning device. Concrete has high compressive strength but virtually no tensile strength. Thus, to compensate for this imbalance, the reinforcement steel is cast to carry the tensile loads. Additionally, a steel reinforcement supplier divides typically reinforcement bars into two, so primary and secondary reinforcement bar. Primary bar aim is to guarantee total resistance needed by the structure, while the secondary aim is employed for durability. Both of these materials are used in concrete structure because they bond well, and this makes the structure resistant to high compression forces presented by the large building. So generally, steel reinforcement gives a concrete structure the stability it needs. It's designed on the principle that steel and concrete act together to produce a stronger structure that can withstand induced forces. Alam natin, hindi naman pwedeng steel lang lahat, reinforcement. So, kailangan din ng concrete na sa construction, kaya maging strong pa yung isang structure. And nonetheless, steel reinforcement has its set of drawbacks, such as corrosion while exposed to salt, but it does provide the necessary strength and durability needed in a concrete structure. So that's all. Thank you.
Okay, good evening, sir. Good
evening, classmate. I am John Paul Tayaban from BSCE2 Non-STEM, reporting for how do we test the tensile strength of steel bars. First, I will read the meaning of a tensile test machine, or TTM. Also known as tension test machine, are universal testing machine specially configured to evaluate the tensile strength of a specimen. Our tensile tester will measure characteristics such as ultimate tensile strength, yield strength, elongation, and modulus. Third, this is the equipment, materials, and tools for testing. First, grease. Second, steel samples. Third, grips. Fourth, rubber bands or springs. At panglima naman is seaming materials, small bars. MTS 634.25F 24F extensometer. MTS C64 206 test machine. USB drives and ladder. And this, I will read also the procedure in testing the tensile strength of steel. First, identify the reinforcing bars to be tested and cut them to a length of approximately 30 inches. Prepare the extensometer for testing. Place the set pin in the extensometer. Add the gauge length extender to the extensometer. Install the knife edge appropriate for the specimen being tested. Install the knife edge appropriate for the specimen being tested. Choose a method to attach the extensometer to the specimen being tested. This may use rubber bands, quick attachment spring, or coil springs. You make the electrical connection between the extensometer and the MTS test controller. Initialize the computer and data acquisition system. Load the test protocol. Create the folder for your test data. Save the data. Install the test specimen in the test machine. Install the extensometer on the specimen. Begin loading the specimen. Export the data. Remove the failed specimen from the grips. Return the test machine to the original displacement position. Save the test. And last, if no more tests that you will do or you will perform, shut down the test machine. Okay, that's all. Thank you for listening. God bless.
Okay, our topic for today's discussion on tensile strength. What is a tensile strength? Tensile strength is the ability of a material to withstand a pulling force, or it's customary measured in units of force customary to the cross-sectional area. This is an important concept in engineering, especially in fields of material science, mechanical engineering, and structural. Standard test for testing strength of steel bar use this our primary use of this test method is to determine the specified mechanical properties of steel, stainless steel, related alloy products for evaluation of conformance of such product to a material. Specification under jurisdiction of a STM committee A01 and its subcommittees as designated by purchaser in a purchase order or contract. The tensile strength of a structural steel bar is 400 MPa and 841 MPa for carbon steel. Tensile test is one of the most common tests for steel. The test is described by standard EN10-002. The test involves training test of piece by tensile force, generally to fracture for the purpose of determining tensile strength, yield strength, and other events like ductility and reduction of area. In a simple tensile test, a sample is typically pulled off its breaking point to determine the ultimate tensile strength of a material. The amount of force applied to the sample and elongation L of the sample are measured throughout the test. What is the minimum yield strength of steel? The minimum yield strength of rebars equals to 400 psi. The allowable design stress is concrete should not be more than 1/3 of the minimum concrete strength. The allowable design stress is steel should not be more than 40% of the minimum yield strength of a steel, or else it will break. Types of load applied in tensile testing is axial loads. The material to be tested when performing tensile testing and the loads applied axially to the body to be tested. It is defined as per unit area, which is associated with stretching and denoted by alpha. It is defined as the amount of tensile stress material can withstand before breaking and denoted by time. The formula is alpha equals force over A, where the alpha is the tensile stress. Many properties of a material may be determined by use of tensile testing. Tensile testing provides data on strength and ductility of metals under unaxial tensile forces. This is somewhat important factor in metal forming process since brittle metals are more likely to rupture. Rupture means destroyed. It is used to find out how strong a material is and also how much it can be stretched before it breaks. This method is used to determine yield strength, ultimate ductility, strain, hardening characteristics, Young modulus, and Poisson ratio. Where is the tensile strength used? Application of tensile testing is in the plastic, rubber, and elastomers industry include joint strength, interlocking plastic components, assessment of material tests, tensile properties, adhesion, or field testing of plastic labels, ID, and credit cards. The tensile strength is usually higher numerical value than the yield strength or particular material. Thus, tensile strength of a material can be ascertained with 100% of accuracy. When talking about steel material, IC 1045 shows a clear difference in its ability to hold greater force when compared to IC 1008. IC 1045 and IC 1018 are still metal, tubular metals. Its ultimate strength is yield, but its yield strength is lower. IC 45 also a great elasticity, meaning it's less brittle. The steel properties of elasticity, yield, and ultimate strength are far beyond those of the aluminums, which makes sense knowing that steel should be far more brittle and aluminum more ductile. With being more brittle, the steel should not come out fracture with more or flat breaks, and aluminum being more ductile should come out with more slanted breaks. That's all for my discussion. Thank you.
And that is our report testing the tensile strength of the steel bars. Thank you. And that is our report testing the tensile strength of the steel bars. Thank you.